Hello guys. Once again welcome back to my YouTube channel. Myself Pavni Raj from SVCE Department of CSE DS. So the subject is Applied Physics and the title is Animation in Physics. So in this section we are going to discuss how the animations are involved in a physics and some application on animations in a physics field. So let us look over our introduction to animation in physics. Animation is a powerful tool used in physics to visualize complex concepts and the phenomena. It allows us to simplify and represent real world scenarios in a more comprehensible manner. Animation helps students to grasp abstract concepts by providing a visual representation of physical phenomena. So let us look over some benefits of animation in physics education. Animation enhances understanding by providing a visual representation of dynamic processes. It allows students to observe and analyze the behavior of objects in different physical scenarios. Animation can simulate experiments that are difficult or impossible to replicate in a classroom settings. So let us look over some types of animation in physics. There are three types: pneumatic animation, dynamic animation, and the particle animation. Whereas pneumatic animation represents the motion of objects without considering the forces involved, whereas dynamic animation depicts the interaction between objects and the forces acting upon them, whereas particle animation focuses on the behavior of individual particles within a system. So, application of animation in physics, like examples like understanding projectile motion, exploring waves, simulating collisions. Under understanding the projectile motion, animation helps visualize the trajectory and factors affecting the motion of projectiles. Whereas in exploring waves, animation aids in understanding by wave properties like frequency, amplitude, and the wavelength. Whereas in simulating collisions, animation allows for the study of conservation of momentum and the energy during collisions. So what are the challenges in creating physics animation or any kind of animations? The first most thing is the accuracy, ensuring that the animation accurately represents the physics principles being portrayed. Realism, striving to create animation that closely resemble real world behavior. Under complexity, balancing between simplicity and the complexity to effectively convey the intended messages. So examples of physics animations are like projectile motion. Animation illustrating the motion of a ball thrown at a different angles and velocities. Whereas in pendulum motion, as we seen in the previous slide, visual representation of the oscillatory motion of a pendulum. And the electric circuits, animated circuits demonstrating the flow of current and the behavior of the components. So best practices for using animation in a physics educations are like align animation with learning objectives. Ensure that the animation corresponds to the specific learning goals. Provide context. Explain the real-world relevances of the animation to enhance the student understanding. Encourage exploration. Allow students to interact with the animation, manipulate variables, and observe the outcomes. So this is an animation which is created by me by using some tools. So while creating these kind of animations or while creating any kind of a character, we need to, one of the most thing is the accuracy. So while creating any character, this accuracy makes the viewer to be very realistic. So let us conclude, the animation is valuable in physics education, enabling students to visualize and comprehend complex concepts. So its ability to simplify and represent real-world phenomena enhances students' engagement and understanding. So by incorporating animation into physics education, we can foster a deeper appreciation and enthusiasm for these subjects. So thank you. This is Pawniraj signing off this today's section.